Hey guys, welcome back to the area of regular polygons. Next couple slides are really just some words that we use sometimes. I don't want you guys to be confused if I use them. Anytime I have a shape with a circle drawn inside it like this, where the circle like just touches all 5 sides or however many sides there are, this circle is called an inscribed circle. Inscribed circle. Inscribed. In meaning inside, inscribed meaning written or drawn. It's like drawn on the inside of the circle. And then I would say that this circle is like an inscribed circle, but we call this circle that's on the outside, it's often called the circumscribed circle. Circumscribed circle. So like circumscribed means like it's on the outside and inscribed means it's on the inside, basically. That's like enough information. So like the inscribed means the circle's on the inside and circumscribed means the circle's on the outside. So this is just, like I said, these are some words that I'm going to use in this next slide for some definitions. So if I talk about the center of a polygon, it's like not maybe so obvious what I mean by the center, but what I mean is if you draw the circle on the outside, which is called the circumscribed circle, it's the center of that circle. And it's usually right where you'd expect it to be, right in the middle. The radius of a polygon is like the radius of that circumscribed circle. And that's like, if you think about it, circumscribed circle is going to touch at all these points, which means this is like this would be called a radius of the polygon. And this is called the radius of the polygon. And this is called the radius of the polygon. This is called the radius. These are all these are all the same length, and they're all, I'd call each one of these the radius of the polygon. There's another length which is going to be very important for us, which is called the apothem, which is not just me saying the word opossum with a lisp, it's actually pronounced apothem. And that's like if you go straight down from the center of the circle, the center of the polygon to the side, this right angle tells you I'm going straight down. This is called the apothem, and that's why I called it A before, because it's the apothem. So this is the apothem. The radius is this other length. We don't use that as often. We use this all the time. And then I mentioned the central angle is like if I have a radius here and a radius here of the polygon, then this angle right here is called the central angle. And we discovered the way to figure out what the value of this is. You take 360 and divide it by the number of sides of the polygon. So for this one, has 5 sides, so it would be 360 divided by 5, which we saw was 72. And if this thing had 8 sides, it'd be 360 divided by 8. And if it had 17 sides, it'd be 360 divided by 17. It's just whatever that number is. That's called the central angle. And there's actually a kind of a formula for the area of a regular polygon, which we don't really need because we saw how to find it just by using triangles, but it's sometimes handy. It's 1/2 AP, where A is the length of the apothem, and P is the perimeter. And this is a pretty handy formula for us. And this one is similar, except it's 1/2 times the length of the apothem. The N here stands for the number of sides. And the S here stands for the side length. And if you think for a minute about the difference between these, it's like this one has a P here and this one has an NS here. And you should ask yourself if P and NS are the same. And for a regular polygon, they are. The number of sides times the side length is going to give you the total distance around, which is what the perimeter is. So these are kind of 2 formulas. They're the same formula. And this really, you can derive this by thinking about the triangles, but we don't have to worry about that. We're just going to, I sometimes use this 1/2 AP. That happens pretty regularly. So I wanted you guys to see this before I did. So let's knock out these two problems real quick. Perimeter and area of a regular hexagon with apothem of length 6. So I'm going to draw this central triangle here. So the first thing I maybe realize is in this problem, they didn't give me the side length. They gave me this length. This is 6 now. Not the bottom, not the side length. They gave me this length, but that's okay. I'm going to do the same thing I did before where I figure out the central angle. In this case, it's 360 divided by the number of sides, which for a hexagon is 6. So that's going to be 60 degrees. But like this little fella here, which is the one I'm going to use to find the lengths in here, is really 30 degrees. That's 30 degrees. It's always half of the central angle. So central angle is 60. This one is 30. And now I can draw my little triangle here, a little model triangle, which I'm going to use to figure out the trig ratios. So now I know that this side is 6. I don't know what this side is. It's like half of the side length. Like if this is 5, then the whole side length is 10. But I don't know. So I'm just going to call it x for now. I know that this angle here is 30. So I can set up my tangent ratio again because I have the opposite side and the adjacent side. I can say that the tangent of 30 is the opposite side x divided by the adjacent side 6. And this looks a lot like the other ratio, except before the thing I was looking for was on the bottom over here. Now it's on the top, which means the rearranging looks a little different. This time I just multiply both sides by 6 and I get x equals the tangent of 30 times 6. And again, that's something I can punch into my calculator. 6 times tangent 30. And I get 3.4641, blah, 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 blah. 3.4641, I don't know, a bunch of other stuff. I'm not going to write it all down. I'm just going to keep it in my calculator and keep using that value. So the area of the whole hexagon is 6 times the area of one of these triangles. And I know the height now, or I knew the height before, but now I know that this little guy here, this is x, which means this is also x, which means the side length is 2x. It's like x plus x, it's 2 x's. And if x is this number, I just hit times 2 in my calculator. And I get 6.9282, blah, 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 blah. 6.9282 and a bunch of other stuff. And that's the side of the hexagon, and it's also the base of my triangle. But just so I show you guys how to use the formula, instead of doing the triangles, we're going to use the formula. The formula for the area of a regular polygon is 1/2 a times p. I know a because it was given to me in the problem. And now I know that this side length is 6.9282, blah, blah, blah. Which means that the perimeter is 6 times that length. This thing is made up of 6 sides, and since it's a regular hexagon, all the sides are the same length. So this perimeter is 6 times that number, 6.928, whatever, whatever, whatever. I put that in my calculator, I get 41.5692, blah, 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 blah. But that's the perimeter, and that's what's going to go right here. So I get 1/2 times the length of the apothem, which was 6, times the perimeter, which was 41.5692, blah, 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 blah. And then I punch that in my calculator. It's at 41, really 1/2 times 6 is 3. So it's 3 times that number, which is in my calculator, and I get 124.708 if I round correctly. And there are no units in this problem, so I don't have to worry about the units. But that's how we do this thing if we're given the apothem instead of the side length. It's real similar, except this step right here where we find the side length is a little different because we just have to rearrange the ratio a little differently. But This is a step that's a little different from before. It's weird how this thing looks like this now, but I'll just move it around. Same question, except this time I'm given the side length, which is what I was given before. So I'm going to do this one. I'm going to use the formula again, but either way, I got to figure out if I have the side length, I got to find the apothem. If I have the apothem, like I did up here, I got to find the side length. So I will have to draw a triangle or two. So I imagine a dot here, and I imagine a triangle exists there. That was a really just mediocre job drawing, so I'll try that again. That's not much better. It's fine. You get the idea. Here's the apothem. I don't know what that is. The side length is 12, which means each one of these pieces is 6. That's A. I got to figure out this angle up here, but I can do that fairly easily. I know that the central angle is 360 divided by 8 because there's 8 sides, which is 45. And that means that each one of these little fellas is half of 45. And 45 divided by 2 is 22.5 degrees. So this guy up here is 22.5. You don't always have to redraw this triangle, but it's fine to do it if you want to, if it makes you feel better, if it helps you do the tangent ratio, might as well. This bottom here is 6 because it's half of 12. This side here is A, and this angle here is 22.5. And so I'm going to do a tangent like I've done every time. And I say the tangent of 22.5 is 6 over A, which means A is 6 divided by the tangent of 22.5, which is 6 divided by tangent 22.5. It's 14.485, blah, 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 blah. 14.485, something else, more stuff. Now, if I want, I can go straight to the formula. I don't actually remember, there was kind of 2 versions of this. There was the one with a perimeter, the one with the number of sides times the length of a side. And now I have the side length, that's 12, and I have the apothem, A, which is 14.485. So instead of finding the perimeter, I'm just going to plug everything into that version of the formula. A equals 1/2 times A times N times S. A is the apothem, N is the number of sides, S is the length of one of the sides. And I have all these numbers now. 1/2 times, this is the apothem, 14.485. Then N is the number of sides. In this case, that's 8. And then S is the side length, which is actually, it looks, it's easy to mix this up and think the side length is 6, but remember this 6 represents half the side length. So the side length is actually 12. Now I punch all this into my calculator. I do 0.5 times that number, which I pull from the previous entry in my calculator. Don't round that yet. Times 8 times 12. That gives me 695.294. I go up and check and make sure, are there any units? There are not, so I can just leave it like this. I can write units squared, it doesn't really matter. And this is the answer, 695.294, whatevers. Maybe I'll leave these last 2. We can do these in class. This one's a little trickier because it's got like kind of a word problem thing happening, but the one above it, part of me wants to be like, do this on your own. It's like, this time it's like you're given the apothem, which means it's kind of like this problem. And the only difference is that now the number of sides is 11. So the central angle is going to be 360 divided by 11, which is not my favorite number, but it's a number. It's fine. You can put it in your calculator. Just make sure not to round until the end. So hope that was vague, at least a little bit clear. And we'll talk more about this in class. Bye.